Hi, my name is Matt Maxwell, and I'm here in an EMI compliance chamber. And with this short video, we'd like to compare the results we get for this device under test in this compliance chamber with the same results we might get in a lower cost setup. As you can see, to have compliance testing, you need quite a large chamber with an elaborate setup. In addition to the equipment you see in the chamber here with the antenna and the turntable that would rotate to allow 360 degrees coverage to check the EMI emissions from the device under test, there's also EMI compliance receivers outside of the room that we'll take a look at later to show the testing in progress. But as you can see, it's a pretty extensive setup, and this is what most devices need to go through, consumer electronic devices, wireless devices, in order to pass compliance test. And actually, they could be much larger chambers than this. This is a smaller chamber, but they can be very extensive setups. So once we have our device under test in the EMI chamber, if we're doing an EMI compliance check, we would use our equipment here to do rotations of the turntable and use the compliant receiver. In this case, we have a CISPR 11 unintentional radiator emissions mass test that we're doing. And we have multiple sweeps captured at different rotations of the turntable that you saw inside the chamber. And we generate a trace here, which we'll show a close-up of, where we can compare the results of each of those traces against the limit lines, the CISPR 11 unintentional radiator emissions lines. And we do this multiple times, and then maybe for full compliance, we might go out to an outdoor full test compliance chamber to complete the testing for compliance. So now we're going to compare the results that we get from the full EMI compliance receiver to the results that we see from the RSA 306B USB spectrum analyzer. So on the PC, we have SignalView PC running, and you see the results of the SPR measurements against the same CISPR 11 radiated emissions test. Again, our device under test is in the chamber here. And you see we have very comparable results. And we'll look at a comparison close up here in a minute, but it's interesting that we get similar results with this USB analyzer to those results that we find with the full compliance receiver. So now we're going to look at the results using the RSA 600 compared with the EMI compliance receiver now for the radiated emissions test against the CISPR 11 limit lines. So with the RSA 600 now, it's a USB controlled analyzer. I've got it connected to the PC running SignalView PC software, and I've loaded up the limit lines here against the CISPR 11 radiator test, less than 20 volts and amps. And I can see the results there. In this case, I'm passing the test exactly like I had done with the full compliance measurement. And we'll look at a close-up to examine the results between those two instruments using the full EMI chamber that I've got here. So here's the results side by side of what we saw on the EMI compliant receiver compared to the RSA. And you can see that they're basically the same shape for the traces. You see a number of spurs on the right-hand side, which is coming from the device under test. And then basically the results are correlating between the fully compliant receiver and the RSA. So the next test is going to be for EMI conducted emissions test. Conducted emissions test means that I have my device under test plugged into power. So here I have an EMI receiver. It's conducting sweeps right now. The device under test is over on the table here, and down on the floor there's something called a line impedance stabilization network. So its job is to allow me to have a test port where I can look at the RF signal coming from the device under test, conducted through the power line that would normally be plugged into the wall, that's being picked up so I don't overrange or overload the EMI receiver. And this is very common for many different devices. I'm again doing a CISPR 11 conducted emissions test here. And I'll look at the results here in more detail, but basically right now I'm failing some of the CISPR average tests and passing the CISPR quasi-peak test. So I might need to take some closer looks with a CISPR quasi-peak measurement at zero span against my sweep to make sure that I'm going to pass the test. But anyway, this shows the basic setup with the equipment performing the conducted emissions test. So now we're going to compare the results that we had from the full compliance receiver with the RSA 607A real-time spectrum analyzer, which is USB controlled. And we can kind of see the results here, the results from the compliance receiver versus the results for the RSA. We're still doing the conducted emissions test per CISPR 11 with our device under test. Line impedance stabilization network, or LISN, is directly behind me. And we can see that the results track very, very closely. And we'll take a closer look at those results here in a minute. But it's the same kind of test for conducted emissions. I haven't changed anything for the setup, and I'm able to get the same results with the RSA 600 series. So here's the side-by-side screenshots comparing the conducted emissions test with the results from the RSA on the lower left compared with the full compliant receiver on the upper right. And you can see here again the traces correlate very nicely. In both cases I'm showing a CISPR peak detected trace, and then I can actually see some failures in this particular case where I've exceeded the limit lines in some of the areas. So here we finally have our device under test set up. It's interesting to note we're in the basement of a large building here, and we actually had to go into multiple rooms trying to find the quietest RF environment that we could use. So now we'll look at the low-cost way of doing EMI pre-compliance sweeps. So the setup here, I have my device under test on this cardboard box. I need some non-conducting surface to place the box on. And I have the low-cost printed circuit board antenna connected to an RSA 600, the same RSA we used in the EMI chamber, along with a preamplifier to help boost the signal level, with SignalView PC running on the controlling the RSA and running on the background. And right now the device is off. You'll notice first off, if you can see the screen here, that the ambient energy in this room is much higher than it was in the chamber. That's what you would expect. An EMI chamber is going to have much better isolation against things like cellular signals and broadcast signals. However, we think the results are still correlating with what we get here in the basement compared to what we got in the chamber. So now I will power on my device under test. It goes through a small boot up sequence. And you see now a series of spurious signals that are coming up that weren't present when I turn off the boards. So with the low-cost printed circuit board antenna, we're able to cover between 400 megahertz and a gigahertz. In order to get the lower frequencies, we need something like a biconical antenna, like the one that I've shown here, down to cover to the 30 megahertz frequency range. So with that setup, I'd also attach the biconical antenna to the tripod and perform the last band of the EMI testing to make sure that I also don't have any gross violations of the limit lines, discounting or ignoring the ambient signals with one more sweep with the biconical antenna. So here for the conclusion, we're comparing the results from those seen in the black and white plot from the full compliance receiver using the EMI chamber with a high sensitivity, high gain antenna, compared with the results in the basement from RSA using SignalView PC. The results correlate. A good point to realize here is that the PCB antenna's lower frequency range is only 400 megahertz, so we really in this screenshot are only comparing the 400 megahertz to 1 gigahertz frequency range. And also a good point to remember is that in the basement I have ambient signals. I have some other cellular or other types of maybe broadcast signals that I'm picking up, so I'm going to have to figure out what those are before I perform my test and identify those. It looks like there may be some cellular signals there around the 800 megahertz range on the basement results from the ambient signals. The point here is that using the CISPR peak sweep on the RSA 600 in this case to compare with the full compliant receiver in the chamber, I get correlated results. I see the similar spurious signals coming from both cases, both measuring the same device under test. And the goal out of this kind of testing is I'm really trying to identify where I'm close to the limit line or potentially exceeding a limit line, failing a test, where some redesign and retesting may be required so that I can avoid a trip to the expensive full compliance EMI lab and hopefully avoid any kind of redesign later on that might be more painful.